Assalamu alaikum. Um,
Walaikum assalam, sir.
okay. Actually, I forgot to create a Google Calendar event. That's why you need to get everybody needs to get permission to access. Uh, anyway, I think we will finish our syllabus today, and tomorrow our will be our last class, and probably we'll do some hands-on examples maybe today or tomorrow, the first part of the class, and then in the second part we will have time to discuss questions and maybe about your confusions or your questions about the final exam syllabus. So let me share my screen. Okay, so what we have covered in the last class, mainly we have covered different categories of multiple access protocols, and also we have covered a very important protocol in computer networking that works in data link layer, that is ARP, address resolution protocol. Can anybody tell me what is the basic purpose of ARP? In short, why we use ARP? Jahara, can you tell me? Jahara, are you there? Okay.
Yes, sir.
Can you tell me why we use ARP? In short, what is the basic purpose of using address resolution protocol? See the name, address resolution. So definitely it actually
Use for
does
address.
something with address, right? Does something with address. But which address? What address?
MAC address.
Yes, MAC address. So uh, we need to know MAC address, right? If we know the IP address. So that is the purpose, because user gives IP address, user doesn't give MAC address. So if we get IP address, how system will automatically know the MAC address? That's the question. So we have the solution found in address resolution protocol, and then we have also covered how it works. There was two cases. In first case, there was no router. That means all the hosts in a single segment. And in the second case, uh, if destination is in a different network. So in the first case, we know the sender sends a broadcast an ARP request that all nodes in the segment receives. Only the node with the IP address, destination IP address, receives the request and creates an ARP reply. And after the reply is sent back to the sender, sender actually updates its own table. And also one other thing, in ARP query that is broadcasted, the destination MAC address is all F, right? All ones, all binary ones, that is in hexadecimal all F, so that every node in the network receives the request and they can match with their own IP. So those the machine with whose IP matches will send the reply. So that is the idea. And after that, that is updated in the ARP table. I have also shown you anytime you can give ARP-A command in your machine, laptop or PC, then you will get the corresponding ARP table. Okay. So this is how ARP works in a single segment. Actually, ARP always works in a single segment, but in case 2, where there is a the destination is in a different network, doesn't matter whether there is a single router in the middle or there are 100 routers in the middle. We know ARP works within the segment, not beyond the router. So that's why there is a default gateway. And when so sender sees that destination is in a different network, the sender will need the MAC address of the router, because sender will send the packet to router default gateway. Okay, router's port. and then router will forward that packet to the final destination like this. So this example we have also covered in the last class, how that actually works and how ARP actually used to send a frame physically to the physically adjacent node. Anybody has any question up to this point? Anybody? So in two cases, two different cases, we have uh, learned how ARP works, and it is a very important protocol because without ARP, system will not work. And also ARP works by default. We don't need to configure anything. Whenever you connect a device in the network, the ARP works in the data link layer. So no question? Okay, then let us move to the next topic, that is the final topic of chapter 6 that we will cover it for the final exam, that is Ethernet switch. So I think all of you have finished computer network lab, where you have found some differences between hub and switch, right, in packet tracer. And there were some differences, but now you know, okay, a switch is much better than hub because switch will only transmit to the destination, and that's why multiple simultaneous communications can be done in switch. So switch is a link layer device. First thing, it works in data link layer, and it takes an active role. That means it receives a frame, stores the frame, and forwards the frame. So in case of router, we saw router stores the packet and then decides, process, and then forwards the packet. In case of switch, it stores and forwards frames, for example, Ethernet frames. And it examines the incoming frame's MAC address, and based on the MAC address, it selectively forward the frame to one interface, one port, or to many ports, outgoing ports, based on the input. You see an example. And also switch uses CSMA-CD to access the segment for link access. So we have gotten basic idea of CSMA-CD, carrier sense multiple access and collision detection, that is used for what? Anybody? Why CSMA-CD is used? Shariful, can you tell me? Sharif, why we use CSMA-CD? Ishrat, are you there? Mahmoud? Shakib? Nazmul Shakib?
Sorry, sir.
Okay. CSMA-CD, I think in the last class we have discussed this a little bit. CSMA-CD is used to give access of multiple devices in the same shared medium. So even if collision occurs, it will detect the collision, it will stop the transmission, and then it will retransmit at a later time so that collision can be recovered. Anyway, so now another property of switch, it is transparent to the host. That means when, for example, host A sending a frame to host B in the same network segment with the help of switch, switch only receives and forwards the same frame. It will not change anything. So host A is sending a frame to host B. The presence of switch is not visible to the host. That's why it is transparent. The hosts are unaware of the presence of switches. That is another important property. And switch actually changes nothing in the frame. Not source MAC and destination MAC. Switch will change nothing. And it is a plug and play. You know, plug and play. So you connect devices to the switch, it will work. It is self-learning. It automatically learns which MAC address is connected to which port that will be used for forwarding a frame later on. Okay, so that these are some of the properties of Ethernet switch. And then the main advantage of switch compared to hub is that we know if two or more nodes transmit in hub, then there will be a collision, right? But in case of switch, since each uh, uh, node is connected to one particular port or interface, so if a node sends data to another node, switch can forward the data, and there can be multiple simultaneous transmissions. Why? Because hosts are connected to switch port, and this port is dedicated for the connection, direct connection, so there is no sharing. And so that's why switch uses protocols like Ethernet. On each incoming link there is no collisions, because this is a point-to-point connection. We know point-to-point connection, there is no collision. In broadcast shared medium there are collisions. And also switch is full duplex, so simultaneously it can send and transmit data. Each link is its own collision domain. So that means whenever you connect a host to a switch, there is a separate collision domain. So if in a collision domain there are only two nodes, there is no possibility of collision. If more than two nodes, possibility of collision. So that's why switch has no collision. But one thing you have to remember, that switch is buffer package. Buffer means it keeps packets in memory. For example, if more than one node sends data to one single destination, and in packet switching, we know in packet switching only one packet can be transferred at a time. Can you remember? We have mentioned during the packet switching L by R. So only one packet will be transferred through the link with the entire bandwidth. So if more than one packet or frame actually reached before transmission, one frame will be transmitted bit by bit as signals, and rest of the frames will be queued up in the buffer. So that is another thing, switches buffer the packets. And in this example, if you can see, there is a switch with 6 ports. So that means 1, 2, 3, 4, 5, 6. There are 6 ports, and 6 devices are connected to the switch. So A, B, C, and then A prime, B prime, C prime, 6 different machines, they are connected to this switch. Now, if I say A is sending data to A prime and B is sending data to B prime, you can see 4 different machines. So there is no single receiver or transmitter. So that's why in this case, both can be done, both can go on simultaneously. So multiple connection can transmit data simultaneously without collisions in switch. That is the main advantage of switch. But if A is sending data to A prime and also C is sending data to A prime, cannot happen simultaneously. Why? Can anybody tell me why this happens? So if destination and source, they are different pair, then simultaneously it can happen, because internal circuitry is made in such a way there is no collision. They will send and transmit using different physical lines. But why, if A sends to A prime and C also sends to A prime, these two cannot happen simultaneously? Any idea? Anybody? No? Again, I would like to ask you to participate in the message box. So even if you give wrong answer, no problem, we can discuss. I expect everybody to participate at least through the message box, so that I know I am connected with you. So if you are understood or not, otherwise I'm blindly just lecturing the concepts. Okay, if in this case you can see the destination is common, right? So A prime is common. So if A prime is common, then switch cannot, because switch to A prime is connected to which port? Can you tell me in the
Uh,
diagram? Yes, port number 4. So if both A and C transmits to A prime, switch needs to transmit those two frames with port number 4. But again, in packet switching, we can transmit only one frame at a time, right? So first arriving one will be transmitted and the second one will be placed in the buffer. So that's why it tells that if A to A prime and C to A prime cannot happen simultaneously, because in this case the transmitter, the receiver is same. So if switch cannot transmit two frames simultaneously in a single link. So that's why. But in this case, the packet will not be discarded. The packet will not be dropped. The frame will be actually, extra frames will be added up in the queue buffer. So that is another thing. Every port or interface in the switch has different memory. So if more than one frame or packet reach to that destination interface, then they will be placed in the buffer and then sent one by one. Is it clear? Okay, so these are the properties of switch. Now let us use a more explicit example, that is the same switch with 6 ports with 6 devices connected. First question, how does switch know A prime reachable via interface 4 and B prime reachable via interface 5? See, to implement the logic, whenever a node transmits, switch needs to know where the destination host is connected, right? Is it correct? Because if A sends
Yes, sir.
C,
So switch need to know the IP address, then MAC address of
no,
destination.
no, switch will not work with IP address. See, be clear about this. Good question, Adrito. I appreciate this type of questions. Switch works at data link. Okay, there are exceptions, but right now we always know, will know, switch works in data link. Data link layer will not work with IP address, right? Data link layer will work with MAC address. So what is the main purpose of switch? To forward a frame received in one interface from a host to forward to another interface, right? Another port connected to the destination. That is the idea. So to do that, switch needs to know to which port that destination is connected. Now the question is, how switch will know that? Did you understand the question? If you understand the question, answer is simple. If you don't understand the question, then answer is not simple. So how switch actually knows? Switch needs to know, okay, if A sends a frame to A prime, switch needs to know A prime is connected to 4. In that case, switch can forward to port number 4, right? But if switch does not know that, actually in that case, switch will work as a hub. So when you connect a switch, a newly bought switch, or just the switch is restarted, so in that case, switch has no table, switch has no information. So in that fraction of seconds time, switch will work as a hub. But since ultimately switch will know which host is connected to which port, then switch will start to work more efficiently rather than hub, because switch now will only transmit to the particular port. Now how that can be done? The answer is, each switch will maintain a switch table. This is called a switch table, or this is called a MAC table, or this is called a forwarding table for the switch. The idea is, in this table, there will be entry of MAC address of the host. So which host is connected to which interface. So the first value will be MAC address of a host. Second value will be interface to reach the host. That means the port to which that host is connected. And the third one is timestamp. Timestamp is actually can be a possible timing, like TTL, how much time this entry will be in the table. This look like a routing table, but again, routing table is maintained by the router that works using IP address. But now forwarding table or switching table of a switch actually has only MAC address and the corresponding port number interface. Okay, now how this table is built up? How this table from start, switch creates this table and maintains this table, that is another question. Okay, is there something like the routing protocol? Actually this is more simpler than routing protocol, and you don't need to configure anything. The switch will automatically do that. How switch will do that? Because switch is self-learned. What is self-learning? You will see an example right now what we mean by self-learning. Suppose there is a switch, 6 ports connected to 6 hosts, and you assume initially the table is empty. Switch knows nothing. Switch is just connected or just started up. Okay. How switch will create ultimately the switch table using the self-learning, that we'll see now. Okay. Suppose there is a frame where source MAC is A and destination MAC is A prime. Okay. Now this is a frame. We know frame contains packets and packet contains IP address, source IP and destination IP. But in this case, we are thinking about the packet is converted to a frame. To convert a frame, the host needs to know the source MAC and the destination MAC, right? I think these concepts we have already discussed before. Okay, so this is a frame. Now what will happen? Please tell me what will happen when this frame is sent by A to A prime through the switch. Can the switch know when it receives the frame, okay, source MAC is A, so source MAC is connected to my port number 1? Yes or no? When switch receives this frame, which port switch will receive this frame?
Port 1.
Right, port 1. Very simple. So if switch receives a frame to port 1, can switch learn? Is it possible for switch to very easily learn that MAC of A is connected to port 1? Yes or no?
Yes, sir.
Very simple. Because it is, this packet is received in port 1. Who is the source MAC? A is the source MAC. So switch can easily learn, okay, A is connected to port number 1. What about A prime? When switch receives a frame with source MAC A and destination MAC A prime, is it possible for the switch to know, okay, A prime is connected to port number 4? Yes or no?
Yes, sir.
How? Others who don't want to ask the question, maybe you have problem with your mic, or you don't want, at least use your message box so that we can interact. So why you think it is possible to know? Okay, you can think, but how it is possible to know for the switch that A prime is connected to 4? Because see, yes,
ওর কাছে তো সবগুলা পোর্টের ম্যাক অ্যাড্রেস থাকবে, তো ও তো তখন ম্যাচ করে করে দেখবে না।
how that is created, that is my question. Should it be available during the startup? Then when you add a new host to the switch, what will happen? Suppose a new host you added to the network connected to a switch, what will happen? Switch knows that MAC address earlier?
No,
Possible?
sir.
Yes, sir.
No. So that's what I am saying. Initially, think about the switch table is empty. Now how that table is created, that what we are thinking about. Okay, so when switch receives a frame through port number 1, that is sure, very simple, switch receives it through port number 1, so the source MAC is MAC of A, must be connected to port number 1. That is very logical. But actually switch will know nothing about A prime being connected to port number 4, because switch did not receive anything in port number 4. You got the point? So whenever it receives a frame, it will update its MAC table or switch table, what is known to it. It knows that, okay, I have received this frame through port number 1 from host A. So definitely MAC of A is connected to port number 1. Is it clear? Yes or no? This is very simple. It receives the interface through interface 1, so it is confirmed that MAC A is connected to 1. But see, it has no information about A prime because the table was empty. I just first added with it. So whenever switch receives a frame from any particular through any particular interface, then switch will add an entry in its table, and this way the table will be populated, right? The table will be generated, and then next time switch will search from the table. But for example, now, is there any entry about A prime in the table? Can you
No,
see?
sir.
No. Initially it was empty. I just added A1, right? So there is no entry about A prime. Now the question is, in this case, what switch will do? Because it needs to send the frame to A prime, but it doesn't know which port A prime is connected. So what it will do? It will flag. It will flag. See? So it will send the packet to all interfaces except one, port number 1, because it doesn't know. So what in this case, switch works like a hub, right? Because switch doesn't know. So that is fine. For the first few attempts, switch can work like a hub, but once the table is populated, then it will not do that. So now how switch will update its switch table? For example, now A to A prime. So now A prime sends a reply to A. Okay, what will happen? Can anybody tell me what will happen? Or you can use the message box. Now A prime sends a reply to A. What will happen?
So switch will know the port number of A prime.
Very good. Simple logic. Simple logic. Now switch receives the reply through port number 4. Now switch is sure, okay, A prime, definitely A prime is connected to port number 4. So I will add one more entry in my switch table. That is the idea. So whenever a frame other than it is configurable, fine. It is configurable. I can configure, okay, port number 1 is connected to that MAC address. I can configure. But in reality, this can change, right? Any host can be connected to any time, especially if you think about the Wi-Fi, right? What will happen? You connect to the Wi-Fi, and then you just leave the Wi-Fi network. Another one connects to the Wi-Fi. So is it possible to or feasible to define this table? No. So that's why it's self-learning. It's automatically, dynamically learned by the switch. Now, whenever,
স্যার
yes,
তাহলে তো যতক্ষণ পর্যন্ত না আরেকজন রিপ্লাই পাঠাইতেছে বা সেন্ড করতেছে ততক্ষণ পর্যন্ত তো সুইচের পক্ষে তার পোর্ট নাম্বার জানা পসিবল।
very good observation, right. But whenever you connect to the network, there are some internal protocols running on, right? Even if we don't send something, whenever you connect and the PC is on, switch is on, they internally do something, and ARP automatically works. We don't need to configure ARP. So within fraction of seconds, within some few seconds, that actually being created. So for the initial part, that is true, but for the data parts. But in this case, we see how that is populated. But in reality, as a user, you will not see anything. It is transparent from the user, right? So let us just move on to know better. So whenever the only update will be whenever a frame is going through the switch, that is for sure. And when a new frame is received by the switch, it will have to decide two actions. Action 1, whether or not to change the MAC table or the switch table. If the entry is there already, no change. If the entry is not there, I will change. And the second action or second decision is where to forward. If the destination is known to switch, that is in the switch table, then it will only send to that particular node. If that is not known, what it will do? Sliding, right? So each possible case you have two options. Okay, now when A prime sends a reply to A, first thing is an entry will be there, first thing. And second thing is, now see, no flooding, because the destination of MAC A is known to switch. So switch will only forward to port number 1. Is it clear? Yes or no? Or if
Yes,
you have any
sir.
question.
Yes, sir.
So similarly, if for example C prime sends to B, B sends to B, so this is actually continuously happened in the network, and then after a few attempts, the switch table will be generated, and then the switch will mostly will send selectively. It says selectively send on just one link, and in that case, switch can support multiple simultaneous connections, communications. Uh, uh, that is why switch is more efficient than hub. Okay. Any question, anybody in this case? So if I give you some question, I think there is a question in the interactive website also, and there are some questions in your workbook also. So possibly we'll do some hands-on tomorrow, first half of the class. So you will, but if you think, okay, any node can transmit to any other node. So based on the entries in the switch table, switch can be have like according to the logic or concept. Okay. Okay, then the last section, actually this is nothing new, we are not learning anything new here, but this is an example. You know, in the entire trimester we have learned many protocols, and also during the start of the trimester I have shown you some animation. I have started with a basic example of web browsing, and I have also mentioned you that don't worry about the technical details now. During the start of the trimester, just think about, just connect with your real life experience of web browsing, and at the end of the trimester we'll see the same example again, and then you will you should be able to visualize what are the things going on here. Okay, if you understand the concepts in this course, what is the target of our course, then we can understand this. And by reviewing this example, we will review the concepts we have learned already. So nothing new. All the protocols we have already covered in the class, either theory or in the computer network lab. So the idea is, this is a synthesized example called A Day in the Life of a Web Request. The name is very attractive one, but basically this is a very simple example of web browsing. Using this example, we will see the steps. We will just review the steps here, but you should be able to visualize on top of your head. So if you can visualize all the steps clearly, that means your concept is clear. If you have some, okay, no, not clear, that means you definitely have lackings of the concepts. You have to go back to the textbook, make clear. But this example will give you some curiosity, give you some scenario where you can check your understanding. And also for the exam, you need to understand the entire scenario. I might ask questions based on this scenario. I don't know what will be the type of question, but if you understand this example, then it will be very simple for you to answer. Okay. Okay, so what is here? Our journey down the protocol stack is now complete. So we have covered application layer, we have covered transport layer, we have covered network layer, we have covered data link layer. Although we did not cover all the things due to the limitation of time, but I think we have covered all the important parts, so that at least we can now categorically connect the things to a single example. Okay, we did not cover physical layer, but we have given some idea. Maybe in some other courses like data communication theory, or digital communication, you'll get more about the physical layer characteristics. But from application to transport to network to data link, and then the next one physical, I think we have a global picture of how networking is done in a single device. Putting it all together, that we call a synthesis of all the concepts. Okay, what is the goal of this part? I think this is 6.7, the last section of chapter 6. Why we actually are going through this. The goal is to identify, review, understand the protocols at all layers involved in seemingly simple scenarios. So all the protocols, if we can remember, we have read HTTP, we have read DNS, we have read SMTP, we have read FTP, we have read TCP, UDP, IP, and also in data link layer we have mainly talked about Ethernet. Okay, ARP protocol also. So using a simple scenario of requesting a www page, that is a web page, I think every day all of us continuously doing this. So I'm doing this in thousands of times. Why not I understand what is actually going on inside? And the scenario is again a practical one. A student attaches laptop to campus network. Suppose you assume you take your laptop to the permanent campus, and then you open up the laptop using the Wi-Fi. Just think about that. And then requests and receives to get the web page of www.google.com. So this is the scenario. This is a school network. Here you can see, sorry, the school network, right? This school network, you can think about UIU network. Although UIU uses 10, right? 10 dot something network in class A. This is also class A, but this is a public network. It shows the public network. And then there is a ISP network. The name of ISP here is Comcast. For example, if UIU takes connectivity from Bangladesh Online or similar some other ISP, then just assume this is the ISP, Internet Service Providers Network, who contains the DNS server. And the last one in the bottom, you can see this is the Google's network. So this is the huge network of Google, where there are web servers, there are email servers, there are many servers served by Google. But in our case, since we are doing a simple web request to access the Google's web page, google.com, so that's why we are showing here only the web server. Clear the scenario? Very simple scenario, and it is very likely to understand the scenario practical in our case also. Okay, now suppose you went to UIU with a laptop connected to Wi-Fi. Now connected to Wi-Fi, that is another step. To connect to Wi-Fi, you have to follow a protocol. Okay, so suppose you just opened the laptop in any floor at UIU, and then the first thing, the laptop needs to get an IP address, right? That's the first thing. So I opened up the browser. I have written like www.google.com. Okay, then enter. So can anybody tell me what protocol we need now? some of the protocols. Just mention some of the protocols. Just we have written www.google.com and press enter, then mention some of the protocols that will be needed now. You can use the message box also. Anyone?
HTTP.
Very good. HTTP is one. Then please, we have read many protocols that will come here definitely. Another one.
TCP.
Which one? TCP.
TCP connect.
Yes, TCP. Shomik, tell you one.
Sir, FTP কি আসবে এখানে?
FTP will not come because we are using web browsing. So FTP is for file
SMTP.
SMTP will not come also because SMTP is used for email. But this will those will be similar. FTP, SMTP will be similar if you understand this example. Any other protocol?
The UDP.
Yes, UDP will come, but it will come for some of the protocols. Okay. For example, DNS uses UDP, right? We need DNS. Okay. Okay. Actually, all the protocols we have studied. So there is not a single protocol that we did not study. But the first thing, as I said, we need to connect to the network. To connect to the network, we need to get an IP address. So normally, we can statically assign IP address, but that is not the case in the Wi-Fi. When you go to the Wi-Fi, there is a DHCP server, and through the DHCP, we got an IP address dynamically. So the first protocol, when we press N, actually before opening the browser, we need to get our IP address. So even if we open the browser, it's still not connected. The first thing, it will get an IP address through DHCP. So DHCP, I think you have completed in the network lab, right? You have configured DHCP. Yes or no?
Yes, sir.
Yes. So everybody configure DHCP. That means instead of statically assigning IP address, we use DHCP. And in case of Wi-Fi, that is needed because suppose every floor at UIU may have maximum 50 connections. So 50 IP addresses may be allocated there. But how many students are there? Many. So I cannot say, okay, each student will get an IP address. That is not feasible in this case. So that is the idea of DHCP. Now, DHCP uses UDP. Okay. So DHCP is an application layer protocol. You can connect to the IPS, Internet Protocol Stack. So the application layer in this case is DHCP because the first protocol we need to connect here because we need to an IP address. Without IP address, we cannot actually communicate. So DHCP, for getting the IP address, there is a DHCP protocol. DHCP uses UDP, and DHCP has a format like DHCP creates a DHCP query, and that DHCP query will broadcast to the entire network to get an IP address. Okay. And then the DHCP request, DHCP is the application layer protocol. So DHCP request encapsulated in UDP and as a segment, and then the segment is encapsulated in IP as a packet, and then that is encapsulated in a 802.3 Ethernet as a frame. So 802.3 Ethernet is the wired LAN. Okay. Although I am saying Wi-Fi, but in this case they are using a wired LAN. Still the same thing. They did not use static IP address. They used dynamic IP address. This is also possible. In a lab, we can also assign DHCP addresses. Anyway, to get the IP, we use DHCP. So first, a DHCP request is being sent. See, it is broadcasted like ERP. It is also broadcasted because it doesn't know where exactly is there any DHCP server there. So it will broadcast. Now for broadcast, we already know for broadcast MAC, Ethernet is the data link layer protocol. So for Ethernet frame, the broadcast address all ones in binary, all F in hexadecimal. So since DHCP request is broadcasted, the destination will be all F on the LAN. So everybody will receive, but only the DHCP server will respond. So in this case, router is the DHCP server. I think in the lab you have also configured router as the DHCP server, right? So router will then reply, and then my laptop will get an IP address. So through the DHCP process, it has some messages transferred, and then at the end of the message, DHCP response will be sent back to the laptop, and then the laptop will be assigned an IP address. So now we have an IP address in the laptop, and it also knows the name and address of the DNS server. Can you remember when you configured DHCP, the DHCP client not only gets the IP address, but also gets the DNS server, but also gets the default gateway, right? In the lab. So although we use DHCP for the IP, but along with it gets the other information also. Now the laptop has the IP address, it knows what is the DNS server, and it knows what is the default gateway, IP address of its first hop route. So this is the first step. Now all the protocols we know, but another thing we have to be clear here, which one will come first, which one will come second. If I say, okay, HTTP will come first, then DHCP, no, that's not possible. Without DHCP, we cannot get IP, and without IP, we cannot browse internet, right? So after DHCP, the next thing is DNS. Why we need DNS? Because we need to get a corresponding IP address of www.google.com. So now the second protocol comes. DNS also uses UDP, and then a DNS query is being created. And as we saw in this structure, DNS server is in the ISP, right? So that is in a different network. So now comes ARP before the DNS and before the HTTP, because to transfer a message to the DNS server, it must transfer the message to the router. To transfer the message to the router, it needs to know the MAC address of the router. Okay. So although we are working with DNS, but when DNS query is created, in that DNS query, IP packet needs to be converted to a frame where we need to know the destination MAC. What will be the destination MAC in this case? Anybody? Assuming DNS server is in a different network, what will be the destination MAC? Anybody? No, we have covered in the last class. It will be the router's MAC. So router, because of default gateway, because the destination is in a different network, the DNS server. So for the DNS query, the source IP is fine, the destination IP is DNS server, but for the frame, the source MAC is the laptop, and the destination MAC will not be the DNS server's MAC, it will be the router's MAC. So then how that can be known to the source? By using ARP. So ARP query is broadcast, we already know that. Then ARP reply will come back. When the ARP reply will come back, now the node, that laptop knows the MAC address of the router, so the DNS query frame now can be finished and then transmitted. Okay, and transmitted through the default gateway, so containing the DNS query forwarded via LAN switch from client to fast hop router. So our router will then forward, using the routing protocol, the DNS query to the DNS server. Now DNS server, see, the routing protocol is used. That can be RIP, that can be OSPF, that can be ISIS, BGP. But they will transfer the DNS query to the DNS server. Now DNS server will receive the query. It will process the query. That means it will add the IP address of google.com in the reply and send back the reply to the source. So now laptop knows, right? Laptop browser knows, okay, this is the IP address of google.com. So now comes HTTP. So after getting the IP address, now we need HTTP request. Now again, to transfer data through HTTP. We know HTTP uses TCP, right? So we need to have a TCP connection. See the sequence. If you understand the concept and logic, the sequence will be fine. So the HTTP to work, we need to establish a TCP connection. We know TCP connection is a three-way handshake, and the first step is SYN segment, where SYN bit is 0. So the request segment is sent to the server, right? And the server will reply with a SYN ACK segment. This is called SYN ACK. That means it's the acknowledgement of the previous SYN segment. This is step 2. So after it come back to the laptop, now laptop knows, okay, I can send data. In the third step, it will send an acknowledgement and it can send some data also. So TCP connection is established. Now HTTP request will be sent through that TCP connection. So without TCP connection, how HTTP request can be sent? So now TCP connection is there. So HTTP request will be sent through the TCP socket, and that request will, using the routing protocols, that request will be reached to the web server of Google, and then Google's web server will create a reply. At the end of the reply, we already saw it in chapter 2, it will add the raw bytes of the file. So in this case, these raw bytes of the file is a web page that was requested. Now the web page, see clearly, the web page will be shown. So previously no web page, but now the web page is shown. You can see the web page from the server is now in the client laptop. Is it clear? So see, this was our purpose. We give www.google.com. We see the Google's page with fraction of seconds, but through that fraction of seconds, all the things done. Clear? Anybody has any question, confusion? Is there anything that we did not cover in the class? Is there anything? Tell me. Just you need to relate, you need to connect the things. Yes, Nuzhat.
No, sir.
Okay. Anybody has any question? So you have to understand this scenario. There is nothing new theory. Just you need to connect your concepts in this example so that you are clear what is happening when. Now we know the underlying details also. So it's much easier for us to understand rather than at the start of the trimester. Right? Okay. So that is end of our chapter 6, and that is end of actually the syllabus. Okay, so the theory ended. Now let me go to a web page. I think, let me show you, I have given an interactive exercise website. How many of you so far browse this? Raise your hand. How many of you? Yes, Aziz, Abu Ammar. Okay, very good. 1, 2, 3, Shahabuddin Sadia, Mahmoud, Mahish Shahriar, Nuzhat, Adrito, Sumaya, Shomik, Nazmus Saqib, Sultan Mahmoud, Samiud Jaman, Rafi, Ashikur Rahman. Very good, my son. Very good. Actually, that will help us. Others who did not browse here, actually this is a good source of resource for you for exercises. Sometimes we say, okay, I need to exercise more. What I like about this interactive website most is, for example, suppose you are going to network address translation in chapter 4. You can see an exercise, right? I have used some of these exercises in my workbook, but this interactive part has very good interactiveness. For example, if you understand the scenario, you can show the questions. All the questions are shown here. Now try to solve each question before you can see the solution. If you see the solution right away, not much help you will get. My suggestion is try to solve all the questions. Okay, you have problems about the theory, go back the textbook. Go back to the textbook. I have mentioned several times, if you don't understand the basic example I have covered in the class from the textbook, it will not be good for you to see only the solution. Okay, then if you are 100% sure, okay, I know the basic example, I am now clear. Now you go through these questions yourself, try to find the answers, and then you match by show solution. You match the answers. If you have confusion, again you can discuss with me, you can discuss with friends, you can discuss with your textbook. Okay, now, okay, you see, okay, I have now understood this example. Now I want to practice. That is the beauty of this website. I like it. Although not all the topics are covered here, but most of the things, especially the things that needs more visualization, covered here. So if you think, okay, I am done with this, but I need one more exercise, two more exercise, three more exercise to do this practice, just click another problem like this. It will change the values, it will change the scenario, it will ask you the questions, and then try your answers.
another যখন দেই স্যার ম্যাক্সিমাম টাইমে সেম কোশ্চেনই থাকে জাস্ট ভ্যালুটা চেঞ্জ হয়ে গেছে
Right. Actually, see, when you understand the concept, the course, if you see the questions, see how many questions are there? 9 questions. So that means all possible angles are covered. So I think the concept will not be a problem. But if you want to practice, okay, if I find this solution, is it correct? In that case, values are important. Actually it's not possible to give all possible questions here, right, interactively. Because if I do, I prepare a question, I will not copy this question, I will prepare according to my concept, according to my understanding, to check your understanding, right, to test your understanding. So that is not possible, but at least you get a good source where you can clear your concept. If you clear your concept, it will not be a problem. How I change the question, not a problem. I am sure if you understand the concept. The problem is you are not sure about the concept. You see the solution, so you understand the solution, but you don't understand the concept. Am I correct? Some of the cases, you understand someone's solution or some solution, but you are not sure whether you understood the basic concept. That is the problem. Okay, question? Anyone? Arju or Sadia, you have a question? Okay. Okay. So Shomik, question? No? Okay, I think
No,
you
sir.
raised your hand previous. Okay, no problem. So that is one thing. Now let us show you a similar problem in chapter 6. In chapter 6 we did not cover error detection and correction, so you don't need this. Random access protocols, Aloha, also you don't need this. But this one, link layer and network layer addressing and forwarding, to understand a good to have a good understanding of the concepts, you can solve this example. See what this example says. There is a scenario where there is a router and then 3 different segments, 3 different network segments are there, and there are some points. You can see 1 2 3 4 5 6. There are some nodes, and out of those nodes, 4 nodes are marked as A, B, C, D, and all the nodes have corresponding IP address and the MAC address. And this router has 3 interfaces. All interfaces has the IP address and the corresponding MAC address. So all the information is given here, and it says consider an IP datagram being sent from C to A. C to A. Now everybody please use your message box. we will try to do it all together. Okay, so C is the source, A is the destination. According to the scenario, according to the diagram, what will be the points traversed by a frame or a packet traveling from C to A? Give me the points only. Give your answer in the message box. You got my question? If a packet is sent from host C to host A, which points the packet will travel? Which points? 1, 2, 3, 4, 5, 6. There are 6 points, but which points a packet will travel if I send the packet from C to A?
Sir, can you repeat the source and destination again?
Yes, source is C and destination is A. See here it is specified here, C to A. So source is C, definitely. Okay, IP datagram, and packet is being sent from C to A. It is saying here. Okay, Mahmoud, you got 6421. Nuzhat says 65421. Sultan says 6542. And Sakib says 6421. Okay, I need 2 more answers. Okay, Aziz says 6421. And Enamul says 6421. Okay, Mahir 6421. I think Nuzhat and Sultan, 5 will be not be there. Why? Because C to A means C to the router, right? C to router, and then router to A. Very simple. So C to router is 6 and 4, not 5, because 5 is C to D, if you can see. So 6421, that is the correct answer. So most of you did the correct answer. This is very simple, because if you just see the diagram, we don't need any technical knowledge. If I see the diagram from C to A, we have to first go through 6, then 4, then 2, then 1. Okay. Now these points are actually a point in the link. This is not a device. 6, 4, they are not device. They're a point in the link. So if I say, okay, if packet is going through there, actually packet is going through that point. We are using these points to know, clear our concept, and to know the packet traveling through this point. What is the packet's IP address? What is the packet's MAC address? What is the source? What is the destination? Like this. Now let us see the questions and do one by one. What is the source MAC address at point 6? Again, write your answer in the text message box. What is the source MAC address at point 6? What will be the source MAC address? Okay, in this case, where the IP address and MAC addresses are given in the diagram, you must use the correct full MAC address and full IP address. You cannot say MAC of A, MAC of B. But for now, since it might be in the screen, it's not very much visible. Some of you are using mobile, so that's why you can write MAC of A, MAC of C, IP of A, IP of C, like this. Okay, so what is the source MAC address at point 6? That means what will be the source MAC address of the frame sent by node C? Enamul, you says MAC C, MAC of C, right? Again, in the exam, you cannot write MAC of C or MAC of B if the real MAC address is given. You have to write the real MAC address. Okay, Nuzhat, MAC of C. Mia Muhammad Aziz, MAC of C. Enamul, Anika, MAC of C. And then I need one more answer before I move. One more answer, please, from the others. What will be the source MAC? I think this is a very simple question. Yes, Mahmoud, MAC of C. So all are correct. Very simple question, because C sends the frame. Definitely source MAC will be the MAC of C. Okay. What is the destination MAC address at point 6? What is the destination MAC address at point 6? That means what will be the destination MAC address for the frame sent by C? Nushat says router MAC. Any other answer? Any other answer? Anybody, please? Your answer might be wrong. Don't worry. Just participate and try to understand the concept according to you. Again, what is the destination MAC address at point 6? That means the packet that is traveling through point 6, what will be the destination MAC? Yes, Aziz says router MAC. I need 3 more answers. Shomik says router MAC. 2 more answers before I move. Please participate. Adrita, okay, very good. Samiujaman says router MAC. And Amul router MAC. Adrita already written down the MAC address. Very good. D2 4C. 10 to E. 10 to E is which one? Adrito, I think you did a mistake now. That cannot be the MAC of A because A is in a different network. So we have already mentioned when destination is in a different network, then the source will hand over the packet to the default gateway. So in this case, router's MAC will be the correct answer because C will send the frame to router. Now in this case, I could ask a different question based on ARP. If ARP is not done, then C has no information about router's MAC, right? So in that case, C must send an ARP request. But in this example, we are only concerned about addressing. We assume that ARP is already done. So C knows the MAC address of everything. But the frame C will add router's MAC as the destination MAC. That is case 2 of ARP, if you can remember. Okay. What is the source IP at point 6? Give me the answer. What is the source IP at point 6? Again, this is a very simple question. What will be the source IP? Right. Mahmoud, Enamul, Nuzhat. IP of C, right? Source IP. So C creates the packet. Definitely C is the source IP. What is the destination IP? At point 6. Yes, Sumaya, Anika. Yes, answer is correct. But now, question 4. What is the destination IP of node C? At point 6. That means the packet created by node C. What will be the destination IP? Ajiz says IP of the router. Enamul says IP of the routers. Mahmoud says IP of the routers. Any other answer? Any other answer? Nushat says router IP. One more answer before I move. Sumaya says router IP. Adrita says 131.200. What is 131.200? 131.200. This router IP. But this is not correct because the IP address will be IP of A. Remember the example we have covered in chapter 1 and many places we said source to destination. So source will be IP of C, destination will be IP of A. Doesn't matter how many links are there. Every source IP and destination IP will never change in normal case. Okay. So that will be
স্যার আমরা যখন সেন্ড করব স্যার এটা স্যার পাবলিক আইপিতে হয়ে যাবে না স্যার তাহলে পাবলিক আইপি হচ্ছে
there is no
নিয়ারেস্ট
NAT.
রাউটারে স্যার
There is no
ডিফল্ট
NAT here. There is no NAT here. This is C. This is a. You can think about a network with 3 subnets. There is no internet here. You can think about This is a diagram with 3 subnets. So each subnet is reachable from any other. There is no, because no information is given about the net. You cannot assume net. If that is given in the question, okay, then you can assume, right? So here we are only concerned about MAC and IP addresses, no net here. See, no information in the net. So C will send to A all our local networks. So the destination IP will be IP of A, right? It will be IP of A. Okay, sorry, IP of A. It will be IP of A. Is it clear to everybody? It will be IP. I'm sorry. IP. Okay. It will be IP of A, not up. IP of A. Any confusion? Anybody? So IP address will be the final destination's IP address, but MAC address will change. Okay, now question number 5. Do the source and destination MAC addresses change at point 4? Yes or no? Yes or no?
The question আরেকবার বলুন।
Now the packet will travel from 6 to 4, right? From point 6 to point 4. Will there be any change in source and destination MAC address? Yes or no? That means the question is, there are 2 switches in the middle, right? Will the switch change the MAC addresses? That's the question. Yes or no?
No, sir.
No, I have already mentioned. Switch will not change anything. So the source and destination MAC, source and destination IP in point 4 and point 6 will remain the same. Unless a node changes something, it will be same. So 6 and 4 are 2 points from C to the router. Since switch will change nothing, so the source and destination in point 6 will be same as source and destination is point 4. Is it clear? Do the source and destination MAC addresses change at point 2? Yes or no? That means from 4, it is received by the router, and then router process, and then it goes to point 2. What do you think? Source and destination MAC address will change here? Mahmoud says yes. Sumaya says yes. Anika says yes. Definitely yes. Because, yes, Nuzhat, because router will process up to network layer. So before going to network layer, the data link layer header, frame header must be removed. So previous source and destination will not work now. So router will forward to the link to connected with A. That means router's network layer will hand over to the router's data link layer again, and that will add source MAC and destination MAC in the interface, right? So definitely it will be changed. Answer is yes. Now, what is the source MAC address at point 2? Very simple question again. Keep the answer. Source MAC address at point 2. Nushat says router MAC. Any other answer? I need 5 answers before I move. So please participate. The question is now from router, the packet is somehow, I don't know what has happened, but the router is now going through point 2. So the question is, which one will be the source MAC here? Aditya says router MAC, Enamul says router MAC, Mahir, Maisun, all are saying router MAC, and answer is correct. Since router's data link layer is now creating a new frame, so source will be the router's MAC. And in the exam, you have to write down the MAC address explicitly, like E93748F9EC0AA, the correct interface's MAC address. Okay, what is the destination MAC address at point 2? MAC of A, Mahmoud says. Nuzhat says MAC of A, right? Enamul, Sumaya, Anika. So see, you are doing, those who are doing with me, this is very simple. And I am sure if you get this type of question in the exam, you will answer it first, right? Hopefully. Because if your concept is clear, this type of questions has no confusion, no much more calculation. So very simple. So what is the destination MAC address at point 2? That is definitely MAC of A. And the last question, do the source and destination MAC addresses change at point 1? Yes or no? From 2 to 1, will it be changed? Mahmoud says yes. Nushat says no. Sumaya says yes. So it's a binary so far. Yes, no, yes, no. Anika says no. I need more answers. So there are 2 yes, 2 no's. Okay, Enamul says no. Then Monsieur says no. Okay, now no is becoming increasing, and no is the correct answer because switch will change nothing. So from point 2 to point 1, nothing will be changed. So the answer will be no. Okay, now you can see the solutions and then you can match with us. And here they have given the real MAC address and IP address given in the diagram. So in the exam, you have to show like this. You cannot say like just MAC of A, MAC of B. You have to write down the exact IP address or MAC address given in the diagram. Okay. Any question, anybody? So see, we have done already. We have cleared our idea about MAC address and IP address. Then there are questions about ARP and switch table. Let us stop here today. Tomorrow in our last class, in the first part, we will do some hands-on with some other examples, ARP and switch table. And then in the second part, we will have time for discussion. Okay. So anybody has any question?
স্যার আমাদের ফাইনালের আগে মার্কটা কবে দিবেন?
Out of 75, right? Out of 75. Okay, I'll take some time. Your final exam is on when? October 6. So our class will be suspended on 29th, right? So 29, then 30, 1, 2. Okay, I'll try to upload that by 2nd October in ELMS. Okay, so you will check. And also, if you face any discrepancy about your marks in, I will update all the things there, class test and marks. Just you can send me an email, and then I will take care. And also, I will give you one counseling hour before the final exam. I will update later. Just keep an eye on ELMS. Okay.
স্যার আমাদের ক্লাস টেস্টগুলো তো স্যার 20 তেই কাউন্ট হবে তাই না স্যার, যেটা 25 24 মার্ক ছিল ওটাতে?
Right. 20, but if anybody gets more than 20, then those will be added to some number. For example, if that is 9, then 1/3 must be added. Okay, 1/3 must be added to assessment, and then plus minus 1 2, that will be decided later. But 20 will be the main number, and the extra numbers will be added as 1/3. Okay, that is the idea. Okay, let me stop the presentation. And okay, so I am